structure. And in the case of a high-octane fuel map, for example, all we need to tell it is what the name of this table is, or this X or Y axis is, and where to look for it. The other thing that's interesting to note here is that some maps share the same axis locations. So our high-octane fuel map and our low-octane fuel map, if we look at the address for engine load, on the high-octane fuel map, it's at 6EC8. In our low-octane fuel map, it's also at 6EC8. This is important to understand because if you change the engine load scale on one of these two maps, it will affect the other one. So you have to be conscientious of what shares those same addresses. In most cases, the fuel maps will share their load and RPM scales. The timing maps will share their load and RPM scales, and so on. So it should be pretty logical of how it's set up, but just something to be aware of, that when you change one, you're also going to change the other because they live at the same place. They live in the same address in the ROM. So just like we did in our Evo 9 base XML, if we scroll down to the bottom, you'll see that I've added some other stuff for OBD2 inspection tables. You'll notice that it's a lot smaller of a section here because I don't need to restate how these tables look. All I really need to do is say this table lives at this address, and that's the end of it. This makes writing XML files from scratch really easy for developers or people who are working on patches. They can write the table definition in a base file once and then just define the addresses for a whole set of specific ROM IDs with minimal work. Again, if you need to add information, you're going to be adding it towards the end of this definition file before the end ROM tag. So I just wanted to show you how these tables are set up in XML, so that in the event that you need to add some features to your EcuFlash, you'll be doing it through these XML files. Let's take a look at EcuFlash itself. So before we looked at our high-octane fuel map, we made a few random changes. Now, keep in mind that nothing gets saved unless you save it, so feel free to cancel, close out, and go back in, which I'll do right now just so we can start from a clean slate. We'll close the ROM out. Give me a nice warning. We'll say no. Go back in. So as we stated, the high-octane fuel map gives you your target air-fuel ratio. Now, it's not an exact target air-fuel ratio, but it represents something somewhat in that range in most cases. If you have a highly modded Evo or something that's not even close to stock, your values may be all over the place, and depending on things like your MAF scale, your intake, your injectors, and how well the rest of the tune is combined, the values in this fuel map are very arbitrary. So one car will use one will like one particular type of value, and another car may use something completely different. So don't feel that this fuel map is specific in any way or is universal in any way to multiple different Evos. You don't really want to copy anyone else's fuel map, specifically because you have no idea if their setup is anywhere close to yours. So just to give you a general overview of what lives in the EcuFlash as far as what tables you have access to. The fuel map and the timing map are probably the most commonly edited maps. If you're familiar with tuning already, you probably specifically have been looking just for these guys right here, first and foremost, because ignition timing and fuel are probably the two key components to tuning a car. If you're not familiar with tuning at all, we'll get into tuning practices in another video. Some other things you'll have access to here are specific rev limits and speed limits. In this case, we've got our stationary rev limiter from the factory is set to 5,000 RPM, and our engine rev limiter 7606. Now, you may wonder, why is it 7606? Well, this is a good, important thing to bring up. If we try to set this guy to 7600, you'll see it doesn't go to 7600 exactly. It goes to 7599. And the reason that is because if you remember, this 7599 is not what's stored in the ROM. It stores another number which is converted to 7599 for your viewability here. So if you're trying to change a value in any EcuFlash map and it won't get to exactly the value you're trying to get to, it's probably because it needs to round off, because this is not a precise number, it's a converted number. So we'll just set that back to 7606. Now, one thing I want to state just kind of off the bat is that the knock sensitivity maps and so on, while they may have some use for advanced tuners, people with built engines that need to specifically retune the knock sensor to eliminate phantom knock, you don't really want to touch these if you're a novice tuner or if you have a stock or mostly stock Evo. Mitsubishi has set up the knock sensor very well from the factory. It's very efficient, and if you have a problem with knock, the last thing you want to do is come into these maps and start messing with the knock sensor thresholds. The first thing you want to do is try to fix your tune. Try to get it to stop knocking. Now, if you remember, when we bumped out into that XML directly, we looked at something called blobits, and those can be represented here. Actually, why don't we look at the OBD2 maps, because that's what we looked at in the XML. So look at the OBD2 inspection maps. This is an example of a blobits map. So it's our 8 bits that make up the 1 byte. Now, if you do try to edit something in these values, you may notice that there's a problem. If you hit equals and type in 1, the value doesn't hold. I can try it again, it just does not hold. So that's just kind of a deficiency with EcuFlash. When you're editing a blobits table, you have to use the increment or decrement keys on the keyboard. So the right bracket and the left bracket. Maybe that'll be fixed or changed in a future version, but for now, if you're trying to change a blobits table, if you're trying to change a single bit, just do it with the increment or decrement and not with the equals. Before, again, we get into any specific type of tuning practices, I want to educate you or let you know of what the MUT table is. So Mitsubishi has created their own protocol for data logging and for diagnostics, system diagnostics. It's called the MUT protocol, and you're probably familiar with a program called EvoScan that can take advantage of this protocol for data logging purposes. So if we bump out to EvoScan real quick, so EvoScan lists a bunch of different things that we can data log, and it lists them along with a request or a request ID or a request address. This actually corresponds directly with your MUT table in your ECU. Now again, if you don't have a MUT table listed in EcuFlash, you're going to have to add it to the XML before you can see it. And I recommend it's one of the first things you do when you're trying to tune your Evo, because having access to this MUT table is key in setting up the ROM before you do any tuning at all. You're going to want to make some changes to the MUT table in order to make data logging more beneficial to you and make it much easier to tune. So what you want to do is get your MUT table listed. You can find the official 2-byte thread in the EcuFlash forum on Evolution M. The official 2-byte thread should list your ROM ID, and whatever XML that's needed to paste into your ROM ID's XML file. And once you paste that XML in there, close out EcuFlash and reopen it, you should have a MUT table listed here, which you can then click on and expand into this giant 3D MUT table, which is essentially a list of addresses. Now obviously this doesn't make any sense to anyone just looking initially. We can't really tell what any of this means, so allow me to explain. So in EcuFlash, when I said that the request ID here corresponds with a MUT table address, what that means is when we want to log RPM and EvoScan, what we're going to do is we're going to log MUT21. MUT21 is associated by, as you can see, the y-axis here explains that this is MUT2x, so everything on this row is MUT2. This first one here will be MUT20, 21, 22, and so on. So if we need to look at RPM at request 21, we're going to look at MUT21, 6B29. What this represents, now this is very important if you're going to understand how EvoScan works, you understand how the MUT table works, and if you're going to understand what it is that you're doing when you come in here and change these values. This value, 6B29, is an address in your ROM that will return the current RPM of the engine. So all EvoScan is doing is saying, whatever is in MUT21, I'm going to assume that that's RPM. If we go in here and we change MUT21, it won't be logging RPM anymore. It'll be logging some other value, that some other memory address in the ROM. So 6B29 is